Okay, we are back. Hello, welcome to another week of watching me solve FNF code. Cool, so I haven't set up today's files yet, so I should do that now. So usually I just take one of the old ones and I copy paste it. Yeah, just to make a new one, and then I go and change it to make it usable. It's the fastest way to do this. Cool, and then I need to open the input file as well, just to get rid of all that stuff. Cool. And yeah, I think I might have mentioned this on like the first day or the second day, but I use this program called Entra. I'm not actually sure where it comes from, but I think one of my colleagues mentioned it to me, and if this isn't the best way to use it, do let me know. But this is just how he showed me how to use it, so that's how I use it too. It does feel a bit redundant though, so I'm not sure. Anyway, that's that. So if I remember correctly, yesterday didn't do too well. I got quite stuck on the question. I think, yeah, it was a graph-based question, and we got quite stuck. 800, but we did get under 400th for the second part, so that's not bad. Oh, no. I'm reading this upside down. What am I saying? Yeah, we got 710 for the second part because I messed up the... I forgot to add on the bags, the top level bags. I'm already dreading explaining my thought process today. But we'll see. Hopefully today will be the day that we get on the scoreboard. Usually sometime around the second week is when I finally manage to do something like that. So I'm excited. 2.5 minutes to go before it starts. So I was doing a bit of recording just before this, music. Something I do in my spare time, if I have spare time. And it was quite fun because I hadn't done that in a while. I don't know why I brought that up, but I guess it's good to have multiple hobbies, not just one. Programming is one of them, and music is another one of mine. Let's see. Yeah, not much to do today except for waiting for the problem to get released. Oh, yeah, so last night I did try to, after I finished streaming, I did try to write a short, I guess, library to pull down the input automatically. But it was quite weird in JavaScript. As far as I can tell in JavaScript, once you do something async, everything has to be async all the way through. Either with callbacks or with async await. And just for what I wanted to do, I'm not sure I want to have to make this file everything in here async await, because there's just a lot of extra boilerplate keywords that I don't really want to have around. So if there's a better way to do that, let me know as well. Yeah, I wanted to do some like smart thing where if I don't have it cached locally, it would go to the website and download it, and then save it to a file, so then the next time I run it, it's fast, and also so their servers don't get overloaded by me spamming for requests. Yeah, I guess you could do some sort of top level await. I think Node does support some sort of top level await, but I haven't looked into it. I think when I googled for it, there was some top level, there was some global flag you could set, experimental flag you could set to do some top level await. But yeah, I think overall, like, this is costing me like 10 seconds. And so I may as well just copy paste it. Okay, yeah, so I'm quite behind. I think this is Node 13. I'll have to look into that. So thanks for letting me know, Blue Ghost. Anyway, let's get going. Oh, Is this? Yes! Yes! It's a opcode kind of question thing. I love these questions. These are like my favorite questions. All right, let's see. So, one instruction per line. Ack, jump or not at the moment. Ack increases by the value, so I'm guessing the value can be negative as well. Yep. Jump jumps to a new instruction relative to itself. So jump plus 127, I'm guessing, yeah, we'll go to 127. Not stands for do nothing. The instruction below it is immediately executed next. This is an infinite loop. The program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Immediately before the program would run an instruction the second time. Ooh, that's a bit tricky for an end condition. Run your code. Immediately before any instruction is executed a second time, what is the value in the accumulator? All right, these are my favorite kind of questions. I'm ready to go. So we need to parse this into something we can use first. So let's go. So for each line, we're just going to split on the space, as I always do. That cool. So the command is going to be the first value and the operand, right? The value. I can't think of the right name for this right now. I'm going to call it prog. So prog.push. I'm just going to put it as an array. Ooh, actually, can JavaScript parse integers with a plus in front of it? Yes, they can. Yes, it can. All right, so cool. So I'll just do that for now. Cool. So we need to keep track of which instructions have been executed as well, right? So executed. This is, yeah, we'll do it like this. We also need a program counter. So the program counter is which instruction we're currently executing. I think we start at 0, right? We start at 0. Yeah. And so what do? We say while we haven't executed an instruction, right? So while executed PC equals null. So I think we can do that, right? A 0 is null is true. Yes. Yeah, that's fine. Why not use number? Because I am old school and I haven't programmed in 2 years. If there is a better way, yeah, I will do that. I will look that up and be sure to use that next time. But yeah. Yeah, so a little bit of background, I haven't programmed for around 2 years. So this is all like 2-year-old knowledge. So while we have null, we want to execute the next instruction. So we will switch the command. Const command val equals executed equals prog PC. We want to switch the command. Case ack, we do something. Case jump, we do something else. Case not, do nothing. We have a value in the accumulator. Does the accumulator start at 0? I'm guessing it starts at 0, right? Yeah. So if it's that, then ack plus equals val. If jump, then PC plus equals val. And we need to make sure we know when to stop. So executed PC has to equal true. Oh, also, PC goes up by 1 automatically, right? So when we jump, because here we will have to add 1. For example, jump to a skip to the next jump 1 will continue to the instruction immediately below it. So I'm just going to double check this. Yeah, but it looks like this will do a PC++, and this will just be PC plus equals val. Does this terminate? It does. I get 45. I'm going to put it through and see what happens. That's not right. All right. That's okay. I'm just trying it out. Jump -4. 1, 2. No, it'll be 1, 2, 3, 4, right? 1, 2, 3, 4. Goes to x plus equals 3, l plus 3. It sets the cumulative 5. Jump -3. It's probably good to just wait. Hang on. It looks like we just ran once. We just ran the first command, right? Ah, NOP. I messed up on the NOP. The NOP has to move the PC as well. 1,600. Alright. Okay, so that was a slight mistake. I forgot to increment my program counter. So the way this works, right, is that it... you know what? I'll finish this first. Part 2. You have exactly 1 instruction is corrupted somewhere. Either a jump is supposed to be a NOP or a NOP is supposed to be a jump. No ACK instructions. Ooh. Program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly 1 jump or NOP, you can repair the boot code and make it terminate correctly. For example, consider that. If one of these was a NOP, it would get to the end. That's so hard. What, isn't this some kind of like halting problem thing? So 0. So 3 is 0. Because even if I change like the first jump or the first NOP, if I change this to a jump, for example, then I have to keep executing the program until I check. So I have to check every single NOP or jump. I guess I can do that, right? I guess I can do that. Oh my gosh, I guess we could do that. Yeah, we just have to test every single thing. So what do I have? I have prog. So I have to copy this. How do you copy an array in JavaScript? I could map to itself. There's a thing I can do somewhere. Dot splice 0. Oops. Yes. Yeah. Good. Thanks for that. Yeah. Forgot about these newfangled shortcuts. Sorry, I don't mean that in any bad way. I honestly just haven't programmed in too long. So for I'm going to do a normal loop for I less than prog dot length I plus plus. If prog I 0 isn't ACK, actually if it is ACK, then we can continue, right? If it's not, then we want to const test prog equals prog test prog I 0 equals, and we're going to do one of these things here. Equals, what was it? NOP. If it's NOP, it becomes a jump. Otherwise, it becomes a NOP. Because there's only 3 instructions, we can do that. Cool, and then we're going to chuck this in here to execute it. We want test prog. Oh, that's it. So when we finish here, we say if PC is, what did it say? 1 after, right? So 1 after would be length. Yeah, dot length equals prog dot length. Success, so console.log. Otherwise, we try the next one. I'm going to print out I as well, just in case. Can't tell if this is infinite looping or if it's yes, I know what I did wrong. Forgot to reset these things. That would be kind of important. It's a bit better. Undefined is not iterable. Well, why would that not be not iterable? Oh, because I'm not copying the I'm not copying the things inside the array, right? I've only copied the array, but I didn't do a deep copy, so I'm changing the actual internal stuff of the array. So test prog actually has to be prog.map that. But it still doesn't, it's still not solving our issue. So it's actually running a lot of times before it does this. And then at some point it says, I can't do this. It is on the 264th time that it can't do it. Why would that be? Oh, right, because PC is, because that was the right one. That was the right one. What? Because that was the right one. While that and PC less than prog.length, right? Yeah, yeah. Of course it can't execute it because it's gone off the end of the array. So that should be right. 700. That's not bad considering how long that took. 15 minutes. All right. Yeah. So I guess that was we just had to do an exhaustive search for every single one and try change every single knob and jump and execute the program and see if we could get to the end. There's this thing in programming called the halting problem where it's supposed to be impossible to tell whether or not a program will terminate or not. And because of that, except by running it, and that's kind of like the theory, right? And so I guess that means, yeah, this was probably the only way to solve the issue. The challenge was to actually exhaustively test every single possible instruction changed from a not to jump or jump to not. Because of that was something that I think it's von Neumann, maybe? I'm going to get this wrong, and I'm going to look really silly. Anyway, so yeah, these kind of challenges are my favorite kind of challenges. So one of the things I'd done before was I'd written, like 3 years ago, I wrote a Game Boy emulator. So it was doing a lot of this kind of stuff where you have code that executes according to a specific specification, and you have to write the code to run that code. And I'm pretty sure, yeah, so last year's challenges, there was this thing they called an int code machine, which was really fun. And you had to, and it wasn't instructions like this where you could read it. It was like 1 means do this, 2 means, like 1 means add, 2 means subtract, 3 means jump, 4 means jump relative, or something like that. So I'm glad this year they made it a little bit easier to read, like human readable, so you could debug it easier. So the general gist of how to write, what do you call it? Something that executes a program is you have this thing called PC. PC is kind of like the standard like CPU nomenclature for this sort of thing. It stands for program counter. And it just means which instruction are we currently executing. And then the other thing is that this computer, this mini computer, the only other thing it stores at the moment is an accumulator. Eventually it might have memory or multiple registers or something like that, but for now it's only got an accumulator. And so these are the only 2 things of this mini computer that we're simulating, are the only 2 bits of information we need to keep track of, right? So we start with the way this program works, generally speaking, is that you execute the instruction and then you add 1 to the program counter so that you know you need to execute the next instruction on the next loop. And that's kind of what we did. So once we had parsed the what do you call it? This program into something that we could manipulate in JavaScript, like what we've got down in the bottom half of my screen, then all that remains is to start with the first instruction and then say, okay, what's the command for that instruction? Is it a jump, is it a not, or is it an ACK instruction? If it's an ACK instruction, then do these things, right? If it's an ACK instruction, the specification says we add the value to the accumulator or minus, but because we've parsed the minus numbers as a negative number, we can still add it. And then we add 1 to the to PC, and it goes up so that we know we need to execute the next instruction. Now, jumps are always a little weird because depending on the CPU, they do one of 2 things. Either it actually jumps that many instructions from the current instruction, or it jumps that many instructions from the next instruction. And so in some CPU systems, if you have a jump -1, that is an infinite loop because jump -1 will go back to the same instruction. But the specification in this specific challenge says that jump +1 goes to the next instruction. So usually jump 0 goes to the next instruction, but in this one, jump 1 goes to the next instruction. So we had to be careful not to, like, for example, take this PC and chuck it out here, which was the thing I wanted to do in my head, because that kind of makes a bit more sense. But in this challenge, it doesn't work like that because of the way jumps work. I mean, you could just say, do this, right? But that kind of looks kind of a little sus. I mean, this also looks sus, right? Because I'm sure, like last year, eventually we're going to keep adding to this handheld game console and do more things. Like last year, we simulated Breakout, and we had to play the game and then like work out what our score was when we played the game, which was pretty crazy. And so for every new instruction that we add, we're going to have to add a PC++ in here. And I'm not sure which way around to do it is better, whether to put a -1 in here and chuck the PC++ outside, or to keep it the way I have it like this. So I'll leave it like this for now. But yeah, so that's generally how we go. So this time I'm definitely going to have to tidy this bit of code up and make it into something a bit more modular, into some sort of library or something, because I am sure that like in 3 days' time, we're going to be adding to this code. And I'm super excited for that. But that's all there is for today. Hope you had fun. Thank you for joining me. And thank you so much to Blue Ghost for showing me all this JavaScript stuff that I had completely forgotten. Yeah, got heaps to learn. So good to see you guys, and I will see you again tomorrow.